some like proportional markup that we charge on everything, then price minus cost would vary, but that wouldn't necessarily be exactly price discrimination, right?
Different proportions of markup?
Yeah, I mean, the way I would define it is like a tendency of the price to track the willingness to pay of the consumers or the sort of elasticity of their demand rather than to track the costs. So like you can think that there are sort of like, you could regress prices on two things, willingness to pay or some proxy for that, and cost. And whatever component picks up willingness to pay, controlling for costs, that I would call, in some sense, price discrimination. Yeah, Jim.
So would like giving subprime mortgages to people who like shouldn't have them, is that an example where they have a different cost than someone else, but if you're giving them a loan at the same interest rate, then you're discriminating?
Yeah, because they might be willing to pay less for the loan. I mean, there's other reasons why you might be doing that,
right.
but yeah, that if the reason you were doing that is that they were willing to pay less for it, and you're trying to just like make sure you still get their business, then actually like even though they're more costly, charging them the same price could actually be an example of price discrimination. Okay, so yeah, in fact, lack of variation with costs. So like things should track costs one for one, right? So if what you find is you run this regression, and in some cases it tracks one for one, right, which should be the coefficient. In some cases it fails to track one for one, but that's in the cases when those people have low willingness to pay, then you'll get a negative coefficient sort of offsetting that, right? And so that's price discrimination. Okay, so let's actually look at the logic of price discrimination, how you want to set your prices in third-degree price discrimination. So before you discriminate against the two groups, the total demand is the sum of the demand from the two different subgroups, right? Let's derive the elasticity of this sum together demand in terms of the elasticity of the individual demands. Mike, could you derive what the elasticity of this sum together demand is in terms of the elasticities of the individual demand? Maybe on the board?
I can give it a shot.
Yeah. Just write down the definition of what elasticity is, right? It's... Okay.
So, definition would be change in demand for change in quantity with price of the quantity.
Yeah?
Change it. How should I define
No,
it?
it's change in quantity.
Yeah, change in quantity down here.
No, it's upside down. You do the change in quantity from a change in price.
Oh.
Yeah?
And the over key, right?
Yeah, and this is the pooled demand, which is the sum of the two demands, right?
Be,
Yeah,
so
exactly.
equals. So then, I'm using the add equation, I guess?
Yeah?
So I need to just...
Exactly. Good.
So, where should I go from here? So the elasticity is just...
So you can separate out those two dq1, dq2 into two different terms, right? Yep.
This is broken down as well. So you could separate this too, right?
And then in order to get the elasticities of those individual demand curves, right, you need to be dividing by their quantity, right?
Okay, by their quantity each, yes.
Yeah.
So then you can, it would just be the sum of their elasticities of demand.
Weighted by the quantities.
Weighted by the quantities on. Is that correct?
Yeah, so you're definitely close. The key thing is that, so we're here, right?
Mm-hmm.
And then what we can do is to get this into an elasticity, we need to divide by the quantity. So we have to multiply by the quantity, right?
Okay.
And so that gives us the elasticity in 1 times the quantity of 1 plus the quantity of 2 times the elasticity of 2 divided by the sum of the quantities. So that's equal to the share-weighted elasticity of the two goods, right? Where the share is how much of the total quantity comes from that good, right? Okay. So the learner rule, absent price discrimination, right, is that price minus marginal cost divided by price is equal to 1 over this quantity-weighted average elasticity. After discrimination, you're going to set the price minus marginal cost equal to the inverse elasticity in that individual market, right? And of course, the quantity-weighted average elasticity has to be in between the two elasticities, right? And so that immediately tells us that discrimination is going to be useful to the extent that the elasticities in the two markets are different, right? And that price is going to rise in the market with the low elasticity and fall in the market with the higher elasticity. We call the market where the price rises the high or strong market, and we call the market where the price falls the low or weak market. Now, output may either rise or fall. Why is that? Well, price is going down in one market but up in the other market, and those could offset each other exactly. One effect could be bigger, the other could be bigger. Social welfare may rise or fall as well. It all depends on whether the effects are bigger in the weak or in the strong market, right? Now, profits are clearly going to rise because this is the firm's choice, right? Otherwise, the firm could always just leave its prices fixed, right? And the problem set is going to ask you to explore whether this potential indeterminacy of profits, of social welfare and output with respect to prices is actually very realistic or not. Okay, so a common application of price discrimination is the design of auctions. Your problem set is due a week from today, right?
No, it's due on Thursday.
Due a week from today. Yeah, I'm pretty sure it's due a week from today.
You said
What? Problem set 4.
oh,
What?
It's good then.
Yeah, I didn't know that.
Yeah, I think it's due on Tuesday, yeah. Okay, so a common application of price discrimination is auction design. Auctions are very much like a monopoly problem, right? Because the monopolist sets reserve prices, right? And Chrissy, in what sense are reserve prices like a monopoly problem?
Like the reservation price, like for your bid, or is the minimum
Yeah.
success? Okay, then that's your like least willingness to pay to get the item that's needed.
So if I set a reserve price, if I raise that reserve price, what does that do? That does two things to me to my profits as an auctioneer.
If you raise the reserve price, and are you just selling one item? Or-
Yeah, let's say you're selling one.
Then that decreases the probability that you'll sell, that it increases your revenue.
The amount you make conditional on sale.
Right. So
Right.
you're trying to maximize your auction profit.
Exactly. So you're trading off those two things, right? Okay. The only difference of this from a standard monopoly problem is that your opportunity cost of selling, right, to any individual buyer is determined by how much the other buyers would be willing to pay, right? It's partly determined by how much you'd be willing to keep it, but it's also, if I sell it to this person, then I can't sell it to the person who's willing to pay the next highest amount, right? So the quantity is the probability of making a sale, and your revenue is the price times the 1 minus the probability that you make a sale, which is 1 minus the cumulative distribution of an individual person's willingness to pay. Now, of course, you have an opportunity cost, which is determined by what could you get from selling it to everyone else, right? But with regards to one individual person, we can think of there as just being like a distribution of that person's willingness to pay, and I have a trade-off between having them pay a higher price, which reduces the chance that I make the sale to them, or a lower price, which reduces the amount that I get from each conditional on the sale, right? So assuming that the marginal revenue that comes out of this is decreasing, right? We're always going to want to award the object to the person who has the highest valuation. Why is that? Well, the opportunity cost of making a sale to this person is that I can't earn the revenue that I would have gotten by selling it to the other person, right? And what's the revenue that I get from selling it to the other person? Well, it's effectively the marginal revenue that I would get from selling it to someone who has the same valuation that he has, right? Because if I, sell it to him at that valuation, then I'm basically earning the marginal revenue that's associated with that particular valuation. So a simple implementation of that is the English auction, right? But this assumes that everyone has the same marginal revenue curve. But of course, if I know that you're willing to pay more for the object than Jim is, then from my perspective, the marginal revenue associated with you is going to be, for any given valuation, lower than it is for Jim, because I'm already way down the distribution of your willingness to pay, right? So in particular, if some buyers are more elastic, some buyers of the good are more elastic, that is, they have a lower willingness to pay, what does the principles of price discrimination say that we should do to take advantage of that? Mohammed?
As an auction or?
Yeah, and an auction.
So in general, we want to be able to sell them at a lower price.
Yeah, absolutely. And so in
auction, if we can separate them, then we can have two different auctions, for example, with two different entry prices.
Yeah, you could do that, but imagine we're putting them together. Remember that I said that the opportunity cost of a sale is determined by everybody else's bid. And then we're going to sort of set a specific to that person price, which says what's the minimum that they'd have to bid in order to beat somebody else at a given bid that the other person makes, right? How would you implement charging a lower price to some people and charging a higher price to other people in an auction like that? Anyone have any ideas? Yeah, Mike.
Greater difficulty in stating your price at all, or entering the auction?
Yeah, you could make people pay an entry fee. That's something you could do. Anything else that anyone can think of? You could handicap people, right? You could say, look, in order to win, you don't just have to be the highest bidder. You have to beat the next highest bidder by a certain amount, right? That's effectively making the reserve price, the price at which the person who's handicapped in favor of has to bid in relative to the person who's handicapped against lower. And the person who's handicapped against has to bid higher than the other person does, right, in order to win. So that's effectively, by the exact same principle of price discrimination, it's raising the minimum price at which they have to bid in order to win, right? So this is a very simple, this is really just exactly implementing the same principles of price discrimination we were doing before, but in this sort of competitive context. What I do is I look at everybody, I say, how much do I think you guys are willing to pay? And I set sort of how much you have to beat the next people by in order to win, depending on sort of my guess of what you'd be willing to pay. And effectively, that creates more competition in the auction, right? Because if one person is not willing to pay that much and the other person is likely to be willing to pay a lot, that's the person who's not willing to pay as much is effectively not going to breathe very much down the neck of the person who is willing to pay more, right? And you can, by effectively leveling the playing field, you're creating